What's up, everyone? We are rounding out our factoring unit today by solving quadratic equations by factoring. Now, before we get started, I'm going to ask a couple of questions that seem kind of random, and then I promise I'll tie it in. So go ahead and answer A, B, and C here. Let me know which of the following you think are true statements. All right, thanks for playing along. 2 times 1 equals 0. Hopefully you were able to quickly deduce that is a false statement here. It's false. Oops. All right, 2 times 1 is 2. And it is not 0. All right, 3 times 0, that was true. And 0 times 394, also true. So the reason I had to answer these questions here is because those actually show us that you intuitively understand this property that you probably didn't even know exists. And it's called the zero product property, or ZPP for short. Now remember, I'm always saying that in math, we're not creative when we name things, but we tell it like it is. And so what I mean by that is zero product property is a property where you have got a product, or the answer to a multiplication problem, that is, you guessed it, 0. And I'm going to show you in a second how this applies to factoring here. So what this property is it tells us that if we have some A times some B, and that product is equal to 0, then we have a couple of things that have to be true. So either A is 0 or B is 0, or this is actually what's known as an inclusive OR, which means that it could be both. So it could be that A and B are both 0. But we're going to investigate all 3 cases. Now, this doesn't only work when A and B are integers or real numbers, but it works with polynomials as well. So here, notice that I've got x minus 1 times x plus 2 equals 0. Well, we can treat this x minus 1 as A and this x plus 2 as B, and use this property the same way. So that means that x minus 1 is 0, or x plus 2 is 0, or both. And then what does that tell us about x, right? So why is this helpful? Well, look at these guys here. These are one-step equations, linear equations that we know how to solve, that we solved in the very beginning of this course. So that means that if x minus 1 is equal to 0, well, I just add 1 to both sides, and I get x equals 1 as one of my potential solutions. Or x plus 2, also set equal to 0. I take 2 away, and I end up with x is equal to negative 2. Pretty cool. So as long as we can take a quadratic here and factor it so that we've got a product that's set equal to 0, we can solve these equations. All right, so I'm going to start you off by giving you 2 that are already factored, and then in question C, we'll do some factoring ourselves. So I've got 2x minus 1 times x plus 2 equals 0. So we're going to use the zero product property. I'm going to set 2x minus 1 equal to 0, and let's solve. So I'm going to add 1 to both sides. So we get 2x equals 1. Divide both sides by 2. We get x equals a half as our first solution. All right, well now we need to set the other factor equal to 0. So we'll have x plus 2 equals 0. And to solve that, we just have to take 2 away from both sides, and we end up with x is equal to minus 2. All right, same thing over here. We've got 2 factors, so that equals 0. So we'll take x minus 1, so that equals 0. Here we just have to add 1, so we get x is equal to 1. Then we'll have x plus 4 is equal to 0. So we've x is equal to negative 4. All right, this next one, we're stepping up our game a little bit. I gave you one that is not factored already, but it's just factoring on GCF. We aren't doing anything crazy here, so we're going to take out an x, and then we'll have x minus 8 left over. The reason I wanted to include this one specifically is because this factor of x out front tends to trip students up, because I think at this point they're thinking about their factors being binomials only, but x by itself here is still one of our factors that we need to set equal to 0 to solve. So we're going to take x and set it equal to 0. And I know that feels silly, but it's already solved for. It just means x itself could be 0. And then we'll take x minus 8 here, set that equal to 0, and we get x is equal to 8. All right, we'll do 2. I need to get back here, and then I'll let you do some practice. So here, we're going to solve the following by factoring first, and then using a zero product property. So first things first, let's factor. This looks like an a is 1, right? It is in standard form. There's no GCF, no leading coefficient. So we're looking for factors of 2 that add to negative 3. So it'll be x is minus 1, x is minus 2. Now we will set each of those equal to 0 and solve. So we'll have x minus 1 equals 0, x minus 2 equals 0. So we end up with x is equal to 1 and 2. See how I wrote those together with a comma? Your teacher might recommend that as well. Instead of writing it as 2 separate ones. But I'm happy with either in my class. All right, next one. This is a difference of squares. So what we're going to do is this is going to factor as 4x minus 1 times 4x plus 1 equals 0. So when we split this apart, they're very similar, right? Except one has a minus sign and one has a plus sign. So we'll end up with 4x equals 1, 4x equals minus 1, x equals plus or minus 1/4. Use the plus or minus here because it's more efficient than writing negative 4 comma negative 1/4 comma positive 1/4. All right, so now you've got 3 more that you can go ahead and pause this video and work through on your own, and then we'll go over them together. Welcome back. Let's look at this first one here. All right, so this was factoring when a was not equal to 1. So we did factors of a times c, or negative 36, that add to b, in this case negative 9. And so we ended up following through factoring by grouping. We ended up with 2x plus 3 times x minus 6 equals 0. We used the zero product property, and we got negative 3/2 and 6. Next one. This was a perfect square trinomial. Look at that. We are getting every single factoring method that we've talked about this unit back in this lesson. It's like built-in review. All right, so we ended up with 2x plus 7 quantity squared equals 0. And so here we ended up, all of our answers thus far have had 2 solutions. But this guy here only had 1, negative 7/2 or negative 3.5, whatever your teacher prefers. And last but not least, this one was fun. We had to set it equal to 0, right? This is important because must be set equal to 0 to use zero product property. So if you didn't catch that, that's okay. But remember, it's the zero product property. It's not the negative 30 property in this case. So make sure you're going ahead and setting it equal to 0 first by adding that 30 to both sides. We took out a GCF, factored, and we ended up with 5 and 6 as our solutions. And just like that, you guys are masters at factoring quadratics and even solving quadratic equations.